We use the left-hand trick to figure out these ordered pairs, but I can never remember like if the 1/2 is the x for either one. So one trick is that if you just fold it in half, the line of symmetry, so if this is 1/2 and then √3/2, then this one would be 1/2 √3/2.
We learned the left-hand tool to remember what the ordered pairs are, but the other issue is remembering which ones are positive and negative. If we think of the unit circle as like a regular graph, we know that quadrant 1 will have both positive, will both be positive. Quadrant 2 will have the first input be negative and the second input be positive. The third quadrant, both inputs are negative, and the fourth quadrant, the first input's positive and the second input's negative. If we forget all the other lines, we can see it looks just like a regular graph, and we can think of it that way.
So, like Alyssa said, it is a graph, but I can never remember negatives even as a graph. So what I do is I've made a slit right here, and this first portion gets folded over. So it's the first portion, and we're taking away, so it'd be the first number negative. So let me fill that in. Now we have this folded over. If we were to fold this one over, we'd then be taking away 2 parts. So both x and y would be negative. And then if I know that the first number is negative up here, then the second number would have to be negative down here. Now, if we just look at the radians of the graph, I realized a pattern that if you take each line, if you follow it all the way across, the denominators are the same. So if you can remember 6, 4, 3, 2, then 6 down here to 6. If you flipped it over on this straight line, then this one would be 6 as well, down here to 6. Same with 4, 3, and 2. We could also remember the numerators in a way of this half over here. If we look at this one quadrant right here, then each of the numerators is going to be 1 less than the denominator and then pi. So pi over 2, so it'd be 1 pi over 2, which is just pi. If 2 pi over 3, so 2 is 1 less than 3, 3 pi over 4, and then 5 pi over 6. And then if we go down to this little area, it's always 1 more. So 7 pi over 6, 5 pi over 4, and then 4 pi over 3, 3 pi over 2. So even though now that you know the denominators over here, it's just a matter of remembering that it goes 5, 7, 11.